So we have seen what is descriptive statistics and what is inferential statistics at a high level. We'll see into details of all the concepts there which are extensively used in AI. Descriptive statistics actually tries to describe the total data. Right? I took one example. If I ask you about any person, you will be explaining it in 4 or 5 sentences. Or if somebody, some warrior went to war, right? Some soldier went to war, and you'd have, had a big fight for a day. But if I ask him what happened on that day, he would be explaining that thing in maybe 4 or 5 sentences. That is actually description of the whole episode. That whole day it was like hell, maybe, right? He might die, he might survive, but he might kill, all that. But he would be explaining that thing in maybe 2 or 3 sentences, like that. Describing that whole scene in 2 or 3 sentences. Like that, we should have some tools to describe the whole data. There may be a billion records, but we should understand it at a high level. Right? To understand the data at a high level, we'll have 2, 3 numbers. Generally, central tendency and variance, right? Standard deviation and z-score, these kinds of 2, 3 numbers will be there, with which we'll try to understand the total data. So those numbers which explain or describe the total data are called as descriptive statistics. Statistic is always about estimation and approximation. We never should expect statistics to perform 100% correct, one thing, and give a result which is like 100%. Okay, so I was having this impression when I was actually in my MCA. When I look at statistics, it always looked like some kind of non-reasonable stuff is being done. Yes, it is. When we don't have all the information, we'll try to get whatever we have and try to derive an inference about the data. We try to understand the data with whatever we have. It is always not guaranteed that you will have all the data. Okay. So descriptive statistics is about describing the that whole data, and inferential statistics is about trying to take small set of data, or maybe small sets of data, multiple sets of small data, and understand the total data. Right? Then generally I'll take exit polls. Exit polls is going to predict who is going to win in next elections. And I never saw a statistician coming to my home and asking whom you are going to vote. The way they are going to do is take some samples from one village, maybe 100 villages, 100 towns, and 100 maybe 5-10 cities, and different kinds of people, different caste, creeds, and economy levels. And they are going to take samples. We call them as samples. Total population is all voters. Vote, there are people who don't have vote. There are people who have vote. All voters is going to be the population for exit polls. Exit polls population. Whatever the business scenario you are trying to solve, or what are the solution you are trying to provide, the target data is the population. Okay, so for exit polls, all voters is the population. For mobile users, all mobile users is the population. So sample, what is sample? From Samsung, 10 people, from iPhone 10 people, from Redmi 10 people, like that. If you take 10 people and make 10,000 people sample, right? You try to understand these subsamples and then try to predict how the behavior is. Like you try to collect for exit polls, you try to collect 100 people from each village, and again from every urban area in a city, 100 people, and towns 100 people. You try to collect the opinions. You take average of all the different hundreds and try to see average of the total thing, and try to find out how the population is. This is called a central limit theorem in inferential statistics. We'll see that in detail, right? So when you look at samples, you will be able to understand population behavior. That is inferential statistics. We are trying to infer the details about population. Okay, so we'll see inferential statistics after we complete pandas, numpy, all the tools we know, like all the tools to practice and do the statistics. But before that, right, we'll cover the descriptive statistics. So central tendency, mean, median, mode. I explained you yesterday. Three measures are there because for each data, one measure may fit. Okay, mean is average, mode is most occurring number, median is when you do sort the data in ascending order and take the middle number. If the middle number is two numbers, then you take the average. Okay, so that's how you calculate. But if you look at this example, in this particular setup, mean is the best appropriate thing, because when you look at the distribution, the data is spread between 54 and 67. Maximum is 67, and minimum is 54. Right? It is around 13. Right? The spread is around 13. 54 to 67. So spread is less. So I can take an average and say that all students are performing at around 60 marks. But if the data is like this, right, we cannot, because there is 15, there is 13, there is 24, there is 17. Data is all over, right? Then you take most frequently occurring number and say that, around 50. Sometimes people are performing around 50, but it is not true. If you really look at the data, it is not true, but this is an approximation. Statistics is all about approximation. We are trying to understand the data, right? If a school has got 1,000 people, the management cannot understand all individually, right? They need dashboards and they need approximations at high level. So this mode fits this data, mean fits this data, median fits this data. Depending on the data, you need to choose the method. What is the use in data science? Generally, there will be nulls in the data, and machine learning algorithms cannot handle nulls. Machine learning algorithms can handle only numbers. Only numbers. It cannot handle text. It cannot handle, categorical columns. Categorical columns means, if a gender is a column, and then there is male and female, there are two categories. Okay, it is not general text. If you take review, right? Review of a restaurant, it's a general text. Somebody will write, I like the food. Somebody write, I like dosa. Somebody like, I like idli, right? So there are different words, different spellings and all that. So it is general text column. And categorical column means only two discrete number of values will be there. 2 or 3 or 4, you can count the number of categories in a column. It is called as categorical column. So machine learning algorithms cannot understand categorical data, cannot understand text. You need to convert everything into numbers. Okay, so these nulls can be converted to numbers or replaced with values which are appropriate to that particular data, that particular column. You took the student's data, one column. If data is like this, you will take mean and replace the nulls. If data is like this, if student marks are like this, then you take mode and replace, because 50 is repeating many times. And if you, right, most probably those nulls may also be 50s. This is one dumb way of replacing nulls, right? So I'll talk about more ways when we actually see. Maybe after a week, right, I'll show an end-to-end execution process of a data science project, where we will use these and then try to understand data. And before we go into depths of subject, right, we will actually see at a high level how we are actually using. Maybe in a week I'll show you. Okay. So here the data is like this, right? The student's data, that particular column, marks column is like this. Then I try to take the median and replace the marks. Getting it, right? Any questions so far? Because it's a recap, I was actually going a little fast. Any questions? Okay. So now we looked at range, mid-range, interquartile range. This one is the one I was explaining yesterday. There will be 3 quartiles. Okay. First quartile is going to be median of the first half of the data. Second quartile is going to be the median of the second half of the data. Sorry, third quartile. Second quartile is going to be the total data's median. This is the median. How do you calculate median? Sort the data in ascending order. Take the middle number, right? That is median. You take the first half and take the middle number, that is median. Here, two numbers are there, so we need to take average here. Here, two numbers, so we need to take average. So when you look at this data, right, it is like we are trying to have three landmarks in the data, isn't it? This is one landmark, the second landmark, and this third landmark. Generally, the data between quartile 1, quartile 3 is going to be mostly valid data, mostly. Okay. So why are we looking at interquartile range again? We have 1 billion numbers or 1 million numbers. You cannot look at each number, right? 1 million numbers you cannot look at. So you take this interquartile range and try to find out quartile 1, quartile 3, and try to calculate 1.5 of quartile 3 and 1.5 of minus 1.5 of quartile 1, and the data beyond those numbers may be outliers. Okay, maybe outliers. I'm saying it is not that it is exactly outlier. I'm not for sure outlier. I'm saying maybe outlier. When I say outlier, the data would have came into the data set by mistake. Maybe there is a IoT device which is actually dumping data. The device got corrupted. No, wrong data got dumped. There is a data entry operator who actually having like fat finger, right? He's actually thinking somewhere else and trying to input the data. Maybe because of that, the data would have been went in to the data set. It may be wrong data. It is like 160 years per a person, or maybe 1600 years per a person, right? Maybe it's a wrong. Maybe they would have typed two zeros there, and there is no validation in the application, and it dumped the data into the database. So those kinds of outlier data can be found with interquartile range. Okay, and when I say outlier data, we will actually take those records and look at those records and try to understand and fix them. Statistics is a tool to give you, clues on when you are actually doing the data cleanup. It will give you clues. So investigation, there are tools for investigation. Getting it right? So interquartile range you understood, right? Balabhaskar, would you like to add something to this?
Yes, sir. Yes, sir.
Please.
This median understanding, most of the people will confuse that. First, we have to ascend the data in a. We have to arrange the data in a ascending order, and then take the positional mean. That means if there are 11 records, middle position. That means this side 5, this side 5, and middle one, sixth position we have to take. This median is also called as positional average. So
Okay.
if you understand that, then only you will understand the median.
Okay. So the terminology is also important. I know Balabhaskar is good at many things here, but he actually added new term, positional average, right? So when you look at the articles, right, generally, I don't know, some of you would have tried to learn data science on your own, but when you try to learn on your own, right, when you look at the articles, the same topic will be written in different way. Terminology, just they change the terminology and write it to make it look like a new thing. It is not. It is nothing. So we will be coining many words there. Right? I said the range, the distribution, right? The spread. Right? These are all different terms we are going to use. So you need to capture those, and some of them will be written here. So try to remember those terms, because in the interviews, when you are trying to attend interviews, you should be coining those words. Then people will think that you know more. That is one misconception. The second thing is, they'll understand that you are in the field for more, for maybe like past 3-4 years. When you are in the industry, then only you will get the terminology. Okay, try to remember terminology. Right? Good, right? Can I move on? Okay. So now we will understand one more concept as called as variance. Okay. So I said that central tendency can explain data, but central tendency may not be sufficient in some data sets. If you look at this data, right, there are students, 20 students, okay, and we'll see how to do these graphs and all that in using code also. The same data I have taken and then built the graphs now. I'll show you maybe Monday. There are 20 students and there are scores in a quiz. Again, one more quiz. Well, this is all data belonging to quiz 1. This is all data belonging to quiz 2. Okay, 20 students, they actually performed like this and like this. And when we took the mean of these scores, I got 7. When we took the mean of these scores, I got 7. But when you look at the graph here, right, I have taken score on the x-axis, you can see, I think, and the students number of students on y-axis. Okay? 6 score got by 6 people in this particular quiz. But in this quiz, right, 6 score got by only 3 people. This guy, and this guy. Okay? And this is called as bar chart. These are called as bar chart. On x-axis, we have taken the label. What is the label here? The score is the label. There are distinct scores, right? Distinct scores here. Right? When I say distinct scores, the score is going to be between 0 and 10 only. Maximum is 10. You see this here? Maximum is 10, right? So 0 to 10 is the score. So when you try to do a graph on x-axis, you will get values from 0 to 10 only. If there are million numbers here, right? If you take the label on x-axis, million numbers will cram, right? Or you are getting what I am trying to explain. If you take a bar chart and put them on x-axis, they are all going to overlap. The numbers are going to overlap on each other, and then you will not be able to see the numbers there. Okay, let me try to explain this. Let me try to explain this by writing. So there are two kinds of graphs. One is bar graph and another is histogram. I was trying to explain what is the difference between bar graph and histogram. Okay. So here, right, in the quiz, the maximum score is going to be 0 to 10. In this also 0 to 10. That's where we chose bar graph here. If the score is between 0 and 1 million, right, 0 and 1 million, it's 0, right? If you try to do a bar graph, what will happen? Here you will get 0, here you 1, 2, 3. Like, at one point in time, you will get 2000, 2001, 2003. Like that, one on top of other, they will get overlap. In that case, right, if the labels are discrete but a big number, or labels are continuous. When I say continuous, between 1 and 2, how many real numbers are there? Between 1 and 2, how many real numbers are there? Do you know integers and real numbers, right? You know reals, integers and real numbers, right? How many are there?
Infinite.
Sorry? Infinite, right? 1.1, 1.11, 1.11, 101, 1.0000. Like the infinite number, that is called as continuous values. Either it is continuous values or the range, the discrete range is high, then we go with histogram. In histogram, what you do is you take ranges on x-axis. 0 to 1000, one range, 1000 to, right, 2000, another range, like that you take. Okay, there are two kinds of graphs. Here we took bar graph because the values are discrete. Okay, the values are discrete. So on the first graph, first quiz, 6 score was got by 6 people, 7 score was got by 5 people, 8 score got by 4 people. But when you look at the other quiz, right, it is different. 5 score got by 4 people, 9 score got by 3 people. The distribution is different. When I say distribution, how many are there for 6? How many are there for 7? How many are there for 6? For 9? How many are there for 8? Right? This is like, it is like, suppose that you are distributing chocolates. Okay? For 8 numbered chocolate, you distributed it to 4 people. 7 numbered chocolate, suppose that each chocolate has got a number rather than a name. 7 numbered chocolate, you distributed it to 5 people. And 9 numbered chocolate, you distributed it to 3 people in one classroom. Suppose that it is not a quiz, it is a classroom. Okay? It is not quiz, it is a classroom. On the other classroom, you distributed 9 numbered chocolate to 3 people, 7 numbered chocolate to 3 people, 6 numbered chocolate to 3 people, 8 numbered chocolate to 2 people. You are distributing chocolates, or the number is distributed across some people, right? It is same. Distribution is nothing but how many are there belonging to one particular category. Here the category is score. Did you get it? Did you get the term distribution? Did you get the term distribution? Any questions there? You need to understand distribution term. It is a simple thing. We'll be using it extensively. Any questions there? No questions also, you should actually respond. That way it will be a bit interactive. Any questions? Everybody is good?
Yeah, we understood.
Okay. So distribution is different. You look at the diagrams, right? You look at the scores here, right? The means here, the central tendency here, it actually looks like same. When headmaster asks, right, how the students are performing in quiz 1 and quiz 2, you can say like, on both quizzes, the average score is 7. But it is not true, right? When you look at the distribution, it is not true. So central tendency alone cannot explain the data. Do you agree with the statement?
Yeah.
When I say 7 on both, the mean is 7. It was unable to explain the data, right? So there must be something else to explain. So graph is one way, right? But when you are talking, right, to other person, right, if you don't have a computer or a laptop or a phone, you cannot show this graph. So there should be a numerical way to express the difference. Okay, variance is the solution. Okay, so the distributional difference, visually seen distributional difference, can be explained using numbers, using variance. So now in these kinds of data, you will try to take mean and variance and then try to explain. Okay, so how that is, I'll explain. So central tendency is not enough to explain data's describe data. Central tendency alone cannot explain or describe data. So we are taking help of other metrics, other numbers. Variance is the other number. Okay, what is variance? We will take mean as the central point. I think I have that is standard. So we'll take the mean as the center point and then try to understand how far each number is from center point. So if you have to, if you see this here, right, there is 7, right, mean 7, mean 7. And other numbers are like, spread is like here, the minimum number is 5, the maximum number is 9 in this. But in this, right, the minimum number is 4, maximum number is 10. Right? When you look at this data, if you look at the minimum, maximum, and the mean, the data is close to mean, right? The 5 and 9 are close to 7 when compared to 4 and 10, close to 7. Do you agree? 5 and 9 in this quiz are close compared to 4 and 10. Right? Do you agree?
Yeah.
Yeah.
Yes.
Right? That what is that explaining? What is that explaining? On the first quiz, students are actually performing like not that well, right? And the second quiz, there are students there who are performing very well, right? So here the maximum is 9, right? So when the spread is close to mean, right? When the spread is close to mean, you can understand that what's happening there. And when the spread is far from mean, also you can understand. If you can calculate that using one formula, that's going to be better. That formula is the variance. So what are we doing here? We are trying to take x and subtract mean and square it and sum it and divide by n. Okay. So I said the mean is going to be the landmark, and then we are trying to measure the distance between the data points and the mean, right? So let me try to take a screenshot and then maybe. So if you have to calculate variance, variance is defined as like this: sigma square or s square. If data is sample, we say s square. If data is a population, when we say sigma square. Okay, sigma square is equal to, right? We are saying mean is the central point, and then we are trying to measure the distance between the mean and the other data points. When I say distance, right, the difference and distance are kind of synonyms. If you ask me what is the distance between Vijayawada and Hyderabad, you will say 200 250 or some number of kilometers. How did we say that? We have some number here and some number there, and we subtracted one from the other, and that's where we got that number, right? Distance and difference are same. Okay, so if I take this distance between this number and the mean is going to be 5 minus 7. Okay, let me take that, plus distance between 6 minus 7, second number. Okay, plus distance between 9 minus 7, right? The data point and the mean we are actually taking. Like that I took distances. But if you look at this, after one point, if you look at this, right, 5 minus 7 is how much? Minus 2, right? 6 minus 7 is minus 1. 9 minus 7 is 2. This 2 is getting cancelled, right? So when you take the distances like this, right, there is a chance that one number gets cancelled other. That way, you will not get the overall distance between the mean and all the data points. Okay. So what are we trying to calculate? We calculated a landmark, that is mean. We calculated a landmark, that is mean. We are trying to understand how far, on an average, how far the data is from mean. Okay. On an average, how far the data is from mean we are trying to calculate. First, we need to calculate how far. Then average we need to calculate, right? So to calculate how far each number is from mean, I am calculating distance, 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 and so on. Distance I am calculating. This part is clear, right? This part is clear, right? Any questions there?
We are clear,
Yes.
Ram.
Yeah. So now I calculated distances, but the distance calculation is wrong. I am saying. When you do this kind of a distance calculation, the positive numbers and negative numbers will get cancelled. So our goal is to calculate the distance. We are not bothered about the units. What is units? I'll talk about it. Okay, in a minute I'll talk about units. Let us square this. Let us square this and let us square this. When you square, what happens? This minus 2 becomes 4. This 2 becomes 4. This 1 becomes 1. Right? When you square it, the negative symbols will go. Positive symbols will go. Everything gets summed up. That way, you will have proper distance. Whether it is negative or positive, it is distance, right? So whether you, it is like, whether it is negative or positive, it is distant. So we need to add it to the original data. Either you have to take a mod. Mod means the mod operation is like taking the absolute operation. Absolute is like whether you have negative or positive, you take positive only. But in variance formula, it is taking square of the distance so that the cancellation effect can be cancelled. There is no cancellation effect. Now we know the distance, right, for all the data points. We know the distance. We need the average distance. That's where we are actually dividing with n. N is what? 20. So this is the variance formula. When you do this, right, what is happening? Square distance is average, you got it. Okay, square distance is average, you got it. Right? When I say average, in general, when you take a data point, you pick this data point, the square distance of that data point from mean is going to be that much. Getting it? That's the variance. Okay. On this data, the squared average distance of the data is going to be less compared to this data. Do you agree? If you calculate, average squared distance of this data is going to be less than average squared distance of this data. Average squared distance is nothing but variance. Average squared distance means this is what? Right? Do the differences, square them, sum them, and divide by your total number. Do you agree with the statement? The average squared distance of this data is going to be less than the average squared distance of this data. Do you agree?
Yes, sir.
Why?
Because the min and max values are far away in the right side.
Yes. Minimum and maximum values on this data set are far away. Right? At a high level, if you look at it as a human being, you can get that. But if there are 1 million numbers, right, we don't know. We never know. Maybe min and maximum are far, but all the data is close. Those two numbers may be outliers. Right? That may also happen, right? Right? There is 4 and 10. There is 4 and 10, but you have taken the total states data, state students data, and minimum and maximum are 3 and 10, but most of the people have got 7 and 8 and 6. What happens? All the data is close to 7, right? When you try to calculate the variance, you will get very less variance, even though the min and maximum. So this is the kind of thought process you should develop. Okay, so you are getting it, right? The thought process should be different. The way we were thinking till we were developers is different. The way we should think when we become data scientists or AI engineers is going to be a bit different. We need to think in terms of mathematics and statistics, and then try to apply business and build models. Okay, we need to cultivate that. From the day one, we need to cultivate that. Okay? The thought process should be a bit different. So now we understood what is variance, right? So if you look at the numbers, generally you may get, but if the numbers are in millions, you may not get. So you use this formula, the variance formula, to calculate average squared distance from mean. The variance definition is average squared distance from mean. Mean is taken as the landmark on data. So if you try to, if somebody asks you like, right, I'm a caveman. Think that I'm a caveman and just now came from the forest to the city, and I traveled from high-tech city, cyber towers to maybe Charminar. Okay, I know that distance only. Okay, you have to explain me how far Bangalore is from Hyderabad. Okay, maybe I traveled from Bangalore to Hyderabad. Only that distance I know, right? I don't know numbers. I don't know kilometers. I don't know miles. I just know that it took some amount of time to travel from Hyderabad to Bangalore. If I ask you, How much is the distance between Hyderabad and Mumbai? How would you explain? Did you get my question? Did you get my question? Should I repeat? Guys?
Yeah, please repeat.
So the question is, I am a kid, right? I don't know kilometers, meters, the metrics, all the metrics I don't know. Numbers also I don't know. You made me travel from Hyderabad to Bangalore. Okay. Now I have to make a trip from Hyderabad to Mumbai. Okay. So I asked you, how far is Mumbai from Hyderabad? How will you explain?
Maybe more or less than the.
Sorry.
Maybe by using time, 12 hours.
Using time, but I don't know even hours also. I don't know. I don't have watch. Right? I don't know. I don't know anything. I don't know what you know. I just know that I just traveled from Hyderabad to Bangalore, and you told me that you need to travel from Hyderabad to Mumbai next week. I asked, how far is it? How far is it? How will you explain?
You will tell them like sunrise you will start, sunset you will reach.
Yeah, that's one way, right? The other way is that, it is 3 times the time it took to travel from Hyderabad to Bangalore. Right? The distance between Hyderabad to Mumbai is 3 times the time it took to travel from Hyderabad to Bangalore. Does it work? Does it work?
May not, because he doesn't know how far it is, right? So
No, he may not know the time. He may not know the numbers, but he has got that intuition, right? Intuition, like I traveled from Hyderabad to Bangalore, and it took some amount of time. It may be sunset, sunrise. It doesn't matter. But if I explain you, right, from here to there, it takes 3 times the time it took to travel from Hyderabad to Bangalore. It will give some intuition, right?
Yeah.
Right. So that's the kind of measures we are trying to develop on data, because each data will have its own units. Right? If you take a data set, that is, if you take a data set like housing price data set, right? There will be number of bedrooms, there will be SFT area, right? SFT area is going to be in square feet. Number of bedrooms is going to be just number, right? Each column will have its own units. So the data should have its own units rather than depending on meters, centimeters, maybe the liters, milliliters. We are trying to develop that. That is the thing. The mean, the standard deviation, the variance, all these numbers are those kinds of metrics. So we know that the center point of the data, right? Mean is the center point of the data. And then we are trying to measure the other data points distances or average distance of other data points. So that on an average, when you pick a data point, it is going to be this far from mean, right? Squared distance. Got it? Getting it? Why the mean, median, mean, standard deviation, mean, variance, and standard deviation, these kinds of measures, why we are developing? Because we wanted to develop the metrics which can explain we are developing the metrics for data that can explain data itself. Okay, we are taking the landmark from the data, which is mean, and we are taking variance, which is from the data, which is trying to explain that how much square distance on an average, the square distance. Variance is going to be one number for the data, for the column. But this column, there will be one variance number, because we are going to calculate distances and take average. There is going to be one mean, one number for a column. Okay? Got it, right? Any questions, confusions? Whatever we are learning, this concept will be there with you throughout your AI career. Okay, throughout your AI career, believe me. Okay, this is the formula. Sigma is the summation. x minus mu, right? First point minus the mean, second point minus mean, third point minus mean, fourth point minus mean. We are summing, squaring, summing, and dividing by m. N is the number of data points. So why we are squaring? To eliminate the cancellation effect. Okay. When the data is a sample, right, you calculate as s square, and the denominator is going to be n minus 1, because when you calculate variance on a mean, variance on a sample, the variance may not be right. The variance measure may not be right. There may be a little less variance than what we see in a sample, because that's where, if you look at the denominator, if it is 20 here, with the population we will be dividing it with 20. With the sample we will be dividing with the 19. If your denominator is a small number, your value is going to be a bit high, right? If your denominator is a small number, the value is going to be high. Suppose that take x, the data is same, mu is also same. You are dividing with 20 here, you are dividing with 19 here. Which number is going to be high? This number or this number? Sigma square is going to be high, or s square is going to be high? Which one is going to be high? Guys,
square.
Anybody?
S square.
S square is going to be high, right? So because denominator is low. Why are we doing that? Why are we dividing when it is a sample? Why are we dividing with n minus 1 is benefit of doubt. Maybe on the population you will have a little more variance. It's a sample, so we are actually taking that, we are giving a number which is a little bigger than what it gives on the sample. Got it? So this is how you calculate. But when you look at this number, right, it is actually average square distance from mean. Average square distance from mean. Okay, average square distance from mean. When I say square distance, if the data is in centimeters, when you subtracted the mean from this point and squared, mean from this point and squared, mean from this point and squared, so it is all centimeter square. The numbers we got are all centimeter square. Okay, and you are summing them and dividing with the total number of numbers. So the outcome is also going to be centimeter square. Right? This is in the squared units of your data. Okay, so you cannot say that on an average each data point is this far from the mean, right? On an average, this far square distance from mean, I can say square distance, but I cannot say if you pick a data point 9, it is 1.5 on an average from mean. I cannot say. To say that, we calculate standard deviation. Standard deviation is simple. Applying square root on top of variance is the standard deviation. We are cancelling that square. Okay. When we calculated variance, right, we had got a square distance measure. This 1.5 is a square distance measure. When you apply square root, right, the square gets cancelled, and you get a number which is in the units of your data. X square's square root is x, right? So you get your number which is in the units of your data. Again, it's an approximation. A square plus b square plus c square plus d square. When you apply square root, it is not a plus b plus c plus d. But we'll take like that in statistics. Okay, square root is going to cancel the squared units, but it is not exactly the square root of the number. Again, statistics. Okay, you just need to take the formula like that only. Okay, square root of 1.5 is going to be 1.22. What is this number is saying is, when you randomly pick a number from quiz 1, a score from a person from quiz 1, his score may be 7 plus 1.2 or 7 minus 1.2. Getting it? Average square distance means what? Average square distance means what? On an average, this is the distance from mean. What is this distance? Score, right? If you randomly pick one student, S5, his score may vary between 7 minus 1.224 and 7 plus 1.22. Okay, got it? It is like 10 minus 4 is 6, 7, 8 point. Did you get it?
Yes, sir.
Are you getting it? So average distance actually explains you that when you randomly pick one data point, so you have mean, you have standard deviation. Now you can understand, right? If you have mean and standard deviation, okay, mean minus and mean plus is this much, maybe most probably, no, most of the students will be, most of the students, not all, most of the students may fall in this range, right? Now it is explaining, right? It is explaining a little better. When I say on an average, students are performing with the 7 score, that was dumb because on the first quiz also quizzes are 7, second quiz is also 7. But now we have this standard deviation. Standard deviation means average. If you pick a random point, how far a data point may be. A data point may be on an average. On an average, we are saying because we took average of square distances and upright square. Okay. So now how far it is? 7 minus 1.9, I can take 2, right? It is 5. 7 plus 1.2, right? It is 9. So on the second quiz, the students may fall between 5 and 9. That actually explains that, on the first quiz, the scores are consistent between, in a range, but they are not performing too well when compared to quiz 2. And at the same time, we may find people who are actually performing low also. So with 2 numbers, I can get more detail, more understanding of data. Without looking at a graph, with 2 numbers, I am actually trying to understand data. Even if that is the data of the total country, like total country students also you can understand. Right? Do you agree now? Do you agree with me? Any questions there? Any questions?
Amma, one question.
Yeah.
So every time after calculating the mean, so we have to and understand and then go for calculating the variance and standard deviation. Is that
No, no,
correct?
no.
Or we have to directly go and calculate the standard deviation every time?
It depends on the data, right? It depends on the data, one thing, and most of the times we'll use visual tools only, not the standard deviation number. Okay. But when we are analyzing data and trying to understand, right, then maybe trying to replace some values, right? So you have mean 7 and variance maybe 500. Can I use the mean number to replace nulls? No, I would say. Mean 7, variance 2. That means the data spread is less, right? Data spread is less means most of the data is close to 7. So most probably these nulls also can be replaced with 7. Are you getting it?
Yes, sir.
Mean is 7 and variance is low. Variance or standard deviation is low. That means data is close to 7. Most probably the nulls are going to fall around 7. Even if I replace nulls with 7, data is not going to get corrupted. When we are actually fixing problems with the data, you shouldn't be corrupting the data. When you corrupt the data, right, the algorithms learns a wrong pattern. It is like this. You are trying to, train your kid or teach your kid, right? So you shouldn't tamper the data, right? So you shouldn't tamper the real world. You should try to teach him the realities. At the same time, you should keep the, that whatever the sensitivity in the kid as it is, right? So if you don't balance these two, right, we know what happens, right? So like that it is. When you are actually trying to correct the data, you are trying to train a kid. Machine learning algorithm is like 5-year-old kid. It cannot do better than 5-year-old kid, right? So you are trying to train a kid. When you are trying to train a kid, the data should be fed appropriately. To a kid, you will talk or maybe show some visuals. because kid will have eyes, ears, and nose, and all the 5 senses. But computer has got only the mathematical formulas, which will be senses for the computer, and the data is the feed for it. The data you feed it properly, the algorithm learns properly. So to feed data, you need to correct data. When you are correcting data, you should not be corrupting it. To get that essence, whether we are corrupting it or not, the mean and variance will be used. Got it?
Yeah, sure.
Yeah. Sometimes, most of the times, we may use both the visual and the numerical. Sometimes we may look at the visuals only and then make a list. Yeah, go ahead. We'll see anyway. Go ahead. Any other questions?
Yeah. So all these comes under the data processing stage.
Yes, data pre-processing. So here, right, we are actually trying to understand the tools now before we apply it. Apply them on the data, right? See this here? These are the steps, right? You look at this. These are the steps. You take data, understand data, and then replace them using data pre-processing, convert everything to numbers. Once after data pre-processing, everything becomes numbers. Now you feed data. In this process of understanding, if your understanding is wrong or the conversion is wrong, the data patterns will not be understood properly and it will not work well on the production and test. We'll see what is test and what is production. But in the test set and on the test set and production plan, then you have to go back and correct it again. After doing all that it is not working, you may have to correct data. This whole iterative process. In this iterative process, all the tools we are trying to learn. Okay. Any other questions? Okay. Try to be as interactive as possible because you can see my face, but I cannot see your face. When I see somebody's face, right, I can know whether you got it or not, and I can actually spend some time in trying to make it clear, right? And one more thing is, while having the classes, right, I'll say some topics are very important, you should definitely understand. I'll say some topics, even if you understand here and there, that's okay. Okay, try to keep that balance because it's an experience. For last 5 years I had, and I'm trying to dump it. If you have to learn everything on your own, it will take 3-4 years, right? To maybe 2 years. If you are a very fast learner, it will take 1.5 years to 2 years. But if you are a slow learner, right, it may take 3 to 4 years. We are trying to dump everything in 6 months. Okay, behold and try to follow whatever is taught here, and then try to learn whatever you want. You are free to learn whatever you want, but finish whatever I explained here, so that there are many dots in this total process of building AI module, and we'll cover all the dots first and then connect all of them. Okay. So if you are not getting connected with some of the other topics, just stop me and ask. Okay?
Sir, one
Good,
question,
right?
sir.
Please.
Is there any classification or any understanding that for this kind of problem we need to apply standard deviation, or we may be applying as a trial and error method?
No, we will. Generally, we will not apply for all the columns. Mean and standard deviation will not find. When there are errors in the data, when there are outliers in the data, right? When the data looks suspicious, then we'll try to use these tools and understand the data and try to make corrections. Right? When there is a problem, then we'll try to. Right?
In data analysis, analyzing the data starts with these concepts of mean,
Yes.
the standard deviation. These are the basics. From here only, the data analysis starts.
Yeah. If you have 10,000 columns, right, you may not do all this analysis. You may take the AI approaches. We'll see those approaches in coming class. Okay. When you have less number of columns and building more, why less number of columns you do analysis is when data is less, right? You need to be careful because data is less. Patterns are very, very concentrated in that small data. You should be very carefully taking the columns or cleaning up the columns. Then only the pattern will be understood appropriately. If data is huge, right? Anyway, the patterns will be identified with algorithm. Got it?
Yes, sir.
We'll see all the things.
Yes, sir, for standard deviation.
But variance formula differs, right, ma'am? Variance formula is n minus 1, right? So here also n minus 1. It's a square root of variance, that's it. Standard deviation is nothing but square root of variance. Variance is the core concept. We are applying the square root because we wanted to bring down the numbers units to the original data unit so that we can actually subtract and add to mean and understand the range. Right? Range, average range, approximate
Okay,
range
sir.
of.
I understood that sigma is for population, so deviation, you showed it as a population. I thought there would be a separate formula for a sample.
Yeah, yes, we'll say s and square root and n minus 1.
Okay, sir.
Here, instead of m, we'll have m minus 1. That is for, that what you call it, benefit of doubt, maybe, the population standard deviation maybe a little more. But to create that a little bigger number, we are taking denominator m minus 1. Okay.
Okay, sir.
So understood, right? I
Yes.
can move on. Any other questions? No. Good. Now z-score. So we know that standard deviation, right? So this data is like a caveman. It knows mean, it knows standard deviation. Average, on an average, how far the data points are. Now we try to measure each distance's data, each data point's distance in terms of standard deviation. I took one example here, right? Previously I said that I traveled from Hyderabad to Bangalore. I know only that. I don't know that is like standard deviation, right? I don't know any metrics or anything. Right? I need to travel from Hyderabad to Mumbai. How will you say that you actually know the distance between Hyderabad and Bangalore? It is 600 kilometers. You know the distance between Hyderabad and Mumbai. You know, I don't know, right? You know it. So what you do? You take 1800, divide it with 600, and you get 3. You say that from Hyderabad to Bangalore is 3 times. Hyderabad to Mumbai it is 3 times the distance between Hyderabad and Bangalore. Got it? Got it, right? So you got 3 because you divided that 1800 by 600 because you know numbers. I don't know numbers. So you are saying 3 times the Hyderabad to Bangalore distance. The Hyderabad to Bangalore distance is the standard deviation. Okay. Suppose that Hyderabad to Bangalore distance is standard deviation. Okay. And you need to you actually have to tell me the distance between Hyderabad to Mumbai. Then what you will say? 3 times the standard deviation. Right? Right? That is z-score. How many times standard deviation this number is, right? How far the data point is from standard deviation. So mean. So mean is 7. 5 is minus 1.63 standard deviations away. Right? 5 is minus 1.63 standard deviations away. I think I should have taken a better number here, but I couldn't. So 8 is 0.81 standard deviation. If you take 7 and if you multiply 8 with 0.81, sum it. Let me try to do the calculation. Z-score is a bit confusing number, but it is very simple. I am trying to make it as simple as possible. Okay? So 0.81 into 8. Okay. No, I think. No. 81 standard deviation here, right? So what is standard deviation here? 1.224 into 0.81 is that much. Okay. Plus 7. Right? It is 8, almost 8. Right? This 7, this 8 is 0.81 standard deviations away. Got it? 7 plus 0.87 into 8 I did. Right? So how far each data point is from mean in terms of standard deviation we are trying to calculate. That is G-score. Got it? Got it? Any questions?
Sir, once again, sir, I couldn't.
Okay, good. Good. Let me try to take a screenshot and explain. See what I did here is,
Put that formula in a reverse mode, sir, so that they can understand. So Z equal to X minus mu by standard deviation, right? You put X equal to mu plus sigma into Z. That's why, that's how we confused. You added 7 and multiplied.
Bala, let me handle it one way. Rather, they'll get confused. I took one path, right? Let me go all the way, and then we'll come back. Okay. So this 8 I want to understand. Okay. I got some score here, 0.81. What is this score? You call this as Z-score. What is that trying to say is 8 is equal to 7 plus 0.81 into standard deviation. Okay. So this 8 is 0.81 standard deviations from 7. What is 7? Landmark. This is mean, right? From mean, how far this 8 is in terms of standard deviation. This is like Bangalore to Hyderabad distance. Right? Mumbai is 0.81 Bangalore to Hyderabad from whatever. Bangalore to Hyderabad. This is Bangalore to Hyderabad. Right? 8 is 0.81 standard deviations away from 7. That is Z-score. Got it?
Somewhat, sir.
Yeah, it takes time.
Yeah, Rama, here we have two units, right? Like score and G-score. So how to derive G-score from the mean and standard deviation?
I'll tell you how to derive. I'll tell you. Right. First, you need to understand the importance of the metrics. Here, I think we have got mean and standard deviation. Right. In this formula, we have mean and we have standard deviation. Right. So we are trying to understand our number in terms of mean and standard deviation. Right. I have my number. Right. This number I wanted to understand from the data set. I know mean. I know standard deviation, right? So what should I do to generate this number, right? I should actually multiply that with it. How to generate this number, I'll explain in a moment, right? So this is called a Z-score. Z-score is one number that explains how far a number is from mean in terms of standard deviation. So to calculate this, right, you need to use formula. Z-score is equal to X minus mu by sigma, right? This number, right, 0.81 I got by subtracting the mean and dividing with 1.224. If I do this right, I'll get 0.81. For every data point, there will be a Z-score, because for every data point, we need to understand how far it is from mean in terms of standard deviation. How far it is from mean in terms of standard deviation. How far it is from mean in terms of standard deviation. We are trying to generate metrics from data itself. There are no kilometers, meters. We are just trying to take mean as the central point. We are taking standard deviation, the average thing, and then calculating Z-score, which actually explains Z-score is the units, right? 0.81 is one number. Like 1 centimeter, you will understand. 2 centimeters, you will understand, because centimeter is a unit. Like that here, Z-score is a unit, right? 0.81 means it is like 0.81 centimeters. 0.81 Z-score, 0.81 centimeters. It is not even 1 centimeter. It is not even 1 Z-score. Right? 1.63 Z-score, that means 1.63 centimeters. You know centimeter on a scale, but the Z-score you need to understand it in mind. Got it? In your mind you need to understand. How Z-score? Right? If you take 9 can be generated by taking the mean and multiplying that Z-score with your standard deviation. This is z-score, this is standard deviation, this is mean. We are trying to generate an equation for each number in terms of mean and standard deviation. The coefficient is going to be the constant is going to be the z-score. The formula to calculate z-score is x minus mu by sigma. X is the data point. Mu and sigma are going to be same for the data set. Mu is one number, 7. Sigma is 1.224 for this particular data set. Got it? Any questions?
One question.
Please.
So how this G-score will help us in the data processing?
I'll explain. I'll
Okay.
explain definitely. That's no whichever word I speak, we are going to use it. You very carefully need to listen the class and very carefully need to follow the slides. Very carefully need to practice. It is all a very planned course. See, one point I'll try to explain. I'll try to tell. This course is not designed to teach. This course is designed to learn. I wanted to learn. I wanted to solve my problems. I want to train my team, right? So whatever is is spoken or shown is all going to be applied because we need to know where to apply. Okay, so that's a good question, and I'll definitely teach. I'll definitely explain. Did you get this point? The z-score point? When we understand distributions, data distributions, tomorrow I'll actually cover data distributions. We will understand the z-scores importance. Okay, normally distributed data and non-normally distributed data, and z-scores and standard deviations are going to play a crucial role. Go ahead, Narayana, please ask you.
No, I understand that. That's what I'm doing.
So if you don't have any questions, right? I stop it here because you need to digest this, whatever the z-score stuff. Ganga Devi, you got the point, right?
Yes, sir.
We are trying to understand or explain each data point in terms of mean and standard deviation. That is this number. When I see 1.63, that means this number, you calculated z-score for one number and you got 1.63. This number is 1.63 standard deviations away from mean. You need to know mean, you need to know the step. In your mind, you should get mean, standard deviation, and then that equation. Mean plus this number into standard deviation is going to be this number. So if it is big number, that means it is far from mean. It is small number, it is close to mean. There are negative numbers and there are positive numbers. So 7 is the center point, and the farther the negative number, smaller the negative number, the data point is far. The farther the positive number, the farther the data point. So you will, by looking at the z-score, you can clearly see how far the data is, how far the data is. Got it? Got it, right? We are trying to understand data with numbers. Even though it is a million numbers, we are trying to understand. Got it? So I'll stop it here and now stop recording especially, and then we'll see if you have any questions.